Here is an explanation for the answer to final exam question number 83 in Alternative Energy Demystified 2nd edition. If you have the printed book, you'll find it on page 329. We're talking about accumulated power over a period of time. How can we express that? In what units can we express that? British thermal units, joules, calories, kilowatt hours, or any of the above? Well, accumulated power over a period of time is just another way of expressing energy. Energy is what accumulates over time when you have a device that dissipates or creates or transfers power. Power times time is energy, so kilowatt hours will work. Calories is another unit of energy. Joules is another, and British thermal units are still another. There are different forms of energy in each of these cases, joules being the most universal and the standard unit of energy. The standard international unit of energy is the joule. But the calorie, well, now you have the actual calorie, or the kilocalorie, which is sometimes called a diet calorie, but that is also an expression of energy. The diet calorie, 1,000 calories, 1,000 actual physical calories, is what you might store in a piece of bread or a piece of meat or something, and then if you incinerate that piece of food outright, you can derive that much energy out of it. That's how they measure calories, generally speaking, in food. In case you're curious, your body may not utilize those calories in quite the same way as just burning them up would, but that's a unit of energy. Kilowatt hours, kilowatts are a unit of power times time, hours being a unit of time, that is another unit of energy. So of course the answer, as you by now have guessed, is E. Any of the above can express accumulated power over time. Well, let's actually take a look now at a little graph I made of power going up and down on the vertical axis. That's power at any given instant in time, and then time moving out along the horizontal axis from left to right, as you would commonly find in a graph. And then we have this red line, which indicates the amount of power consumed at any given time. So, for example, at this point in time right here, well, oops, that's not going to work. Okay, I'll just leave that little blooper in there just so you can laugh at me. At this particular moment in time right here, that's how much power we're consuming. And, you can just follow the graph along. The energy that is consumed between the initial time zero, that would be right over here, all the way over here at the left. That initial time zero right there, and any given moment in time is the area under this curve. That is the area bounded on the top by the curve, on the right by the instant in time, this blue dashed line, on the bottom by the time axis, on the left by the power axis. As we move along in time, the accumulated power increases, so the amount of energy increases. So you might think of this as, here's a 24-hour day. Let's just consider this. Between here and here is a 24-hour day. This is the power that you consume at any moment in time in your house, say, in kilowatts. Well, then the amount of energy that you have consumed in a day in kilowatt hours would be 24 hours times, well, we would have to use integral calculus to figure it out in a curve like this. If the line were simply flat, if it were just a straight line like that, then the accumulated power over time would be the area of this rectangle. That'd be easy to figure out. Say you're burning 5 kilowatts continuously all day long for 24 hours. That'd be 120 kilowatt hours. But generally speaking, in the real world, you burn more or less, and your kilowatt hour meter, your utility meter, your smart meter, or your stupid meter, or whatever it might happen to be, measures this accumulated power. So, and that in a particular unit that it uses is the kilowatt hour. But in the question, any of the choices A, B, C, or D express energy. So again, the answer is E.